This video is about the variations, different types of variations, and we are filling out a foldable that we made in class. So the first variation is called a direct variation. So on the front flap of the first fourth of your paper, you're going to write direct variation, and here's the equation. It's y equals k times x. K is a constant. It's called a constant of proportionality. And you're going to see that in each of the four equations. That k is very important, and it will be different for every equation, and you'll find out that we have to solve for it first. So that's the outside front flap. On the inside of that first flap, on the top of it, you're going to write what this looks like in word problems. It'll say something like y varies directly as x, or it could say y is directly proportional to x. Either way, it's the same way of saying this equation right here, y equals k times x. So a problem would look like this. Y varies directly as x, and y is 6 when x is 4. So I know I'm going to use this equation, and I'm going to plug in my x and the y they gave me in order to find k first. That's my first step. Find k. It says y varies directly as x. Y is 6 when k is 4. So k is here, and 4 is my x. So then I would just solve this for k. Divide by 4. So k equals 6/4. Reduce that and you get 3/2, which is 1.5. Alright, so now my real equation looks like this. Y equals 1.5 times x. At this point, I am prepared to finish the problem with part B. Find y when x is 20. So y equals 1.5 times 20. And I could finish that out, and you're going to get 30. That's my answer. So in order to finish a problem, you first have to figure out what k is. Then plug k into the equation and solve for y. That's what a direct variation looks like. Next is the inverse or indirect variation. You see it described both ways. Here's the equation, y equals k divided by x. So as y is getting bigger, k is getting smaller. That's what the inverse relationship looks like. The more miles I drive, the less gas in my car. Those relationships are everywhere in real life. The way it's going to be described in a problem, it'll say y varies inversely as x, or it could say y is indirectly proportional to x. Either way, it's the same equation. So a problem is going to be similar to before. You first have to find what k is and then plug in the needed values. The problem will give you what you need to solve for k. It says y varies inversely as x. So there's this equation. And y is 4. K is on the top. And when x is 16. Alright, so here's my problem. I need to solve this for k. So multiply both sides by 16. 16 times 4 is 64, so k is 64. So to solve part B, my equation looks like this. 1 equals, that should be k over x, 64 over x. Now I can finish part B. Find y when x is 10. So y equals 64 divided by 10, and that would give me 6.4. Some of these problems will have decimal answers. If that's the case, we round to the nearest hundredth, so 2 decimal places. This one only has a tenth place, so I can stop right here. That's the indirect, so make sure you know that equation, k over x. The third one is called a joint variation, so you have 3 things going on a joint. You'll notice it has a z, that's different than before, and you have 2 variables being multiplied by k. Alright, so it's a joint variation. The way it's described is it'll say z varies jointly as x and y, or is jointly proportional to x and y. So as these go up, z will go up. It's similar to a direct, you just have an extra element in the equation. So here's the problem. If z varies jointly as x and y, well, that should say that should say z is 10 when k is my constant, x is 4, y is 15. So all I'm doing is plugging in to this equation right here. K is my unknown. So I'm going to solve this. 4 times 15 is 60 times K, divide by 60, reduce that, K equals 1/6. Or if you prefer putting that as a decimal, that's okay on these problems. You could say 0.167. Now I can solve for part B. Find z when x is 12, y is 7. I have to put the k value in, 0.167 times 12 times 7. All of that multiplied will give me my value for z. 0.167 times 12 times 7 gives me 14, even 14. That's how I solve for z. Notice you had to find k first, then you can find z. Unfortunately, if you don't get k correct, you're not going to get z correct, so be very careful in that very first step. The last variation to cover is called the nth power variation. On the front flap, here's your equation. Y equals k times x to the nth power. Okay, the way that it will read in the problem, y varies directly with the nth power of x. So it's similar to a direct variation, but x is just being raised to a specific power, and that will be given in the problem. So look at the problem. Again, we have to find the k first, and then we can solve for the final answer. If y is directly proportional to the third power of x, that means it's x to the third times k equals y. And y is 750, k is unknown, and x is 10, that's to the third power, the problem read that. So now I can solve for k. 10 cubed is 1,000, so times k equals 750, divide by 1,000, reduce that, and you're going to get 0.75 or 3/4, however you want to solve that. K then gets plugged into the new equation. So find y when x is 8. Still raised to the third power, because that's what the problem read. Still raised to the third power. So I have y equals 0.75 times 8 cubed, which is 512. And I multiply that by 0.75, and my answer is 384. Okay? So again, solve for k first, plug it into the new equation. You just need to know those 4 equations very well. Direct, indirect, joint, and the nth power. So for your whisk, you're going to solve this problem for me, and you're going to find what is y when x is 4. If this is the description of the equation, y varies inversely with y, x is 24 when y is 8. So set your equation up, solve for k. You have to find k first, and then solve for y. Make sure you follow those steps. Be ready to defend your answer in class. Your answer will go in the whisk, so have that completed.